que Jean-Jacques, évidemment, c'est un courrier critique qu'il a semi-désagréable, il n'a jamais répondu pour les problématiques successives.
Merci à tous les projets. Je passe le colloque de multilingue, je ne sais pas si je peux parler français. One of you doesn't understand French, I can switch to English, but the idea of this meeting is to be multilingual. Donc je vais faire l'introduction en français. Donc c'est la 6e session, je crois, de PhilMathMED, philosophie, histoire, philosophie, histoire et didactique des mathématiques en Méditerranée. Donc c'est la 6e rencontre. Le réseau réunit donc les universités d'Aix-Marseille, Nice, Montpellier, Toulouse et depuis l'an passé Sereni. Et puis on va peut-être s'agrandir encore. Ça serait bien à élargir les partenaires impliqués. Donc cette année, on a choisi comme thème les structures et après. Vous êtes, tous ceux qui ont reçu un message, en tout cas, et donc qui sont enregistrés, vous êtes invités ce soir en Angers, je préciserai le restaurant, on va dire ce soir tout à l'heure, dans l'après-midi. Voilà, donc on va commencer avec l'exposé d'Andrea Sereni, USS Applicability, qui va nous parler de Ceasar Constraint, Applicability, Neologicism. Merci Andrea.
Thank you. Thank you for inviting me and thank you for opening this meeting. I'm afraid my bilingualism doesn't properly include French. So I will speak in English and I'll try to get the conversation in French. I can understand it a little bit, but I hope these and future possibly occasion will be chances to get better on that score. Let me first mention, of course, that this is a joint work with my colleague Francesca Bocconi from the University San Raffaele in Milan. So the meeting here is broadly devoted to structure and their role in mathematics, in the flow of mathematics. This will not be directly a talk about structuralism, but it will be indirectly about it. It will be a talk in which Francesca and I try to point to some problems that we see in one of the major rival in contemporary analytic, if you want, philosophy of mathematics, that is neologicism, the form of logicism that has been championed by Christian Wright and obeyed in the past 40 years. And indirectly, this points to the fact that some of the arguments that they use against structuralists, especially anti-rem structuralism, the form that has been developed by Stuart Shapiro, may not work. So this is indirectly claim that, well, possibly some of these arguments will not be as strong as to favor a Platonist versus a structuralist interpretation of arithmetic. Will be focusing on arithmetic here. So the main gist of the talk would be the following. We will try to put together a number of constraints or a number of requirements that neologicists put or ask for definitions of mathematical concepts, especially the definition of cardinal number, and hence the definition of finite cardinals, and the form of natural numbers. And especially the three notions that will be, the three requirements that we will be focusing on will be the requirement for the sortality of the concept introduced by their preferred definition, details are to come, and what has been called Frege's constraint or Frege applicability constraint, and a requirement on a notion which is very useful but really blurred, and that they ask for definition, that is a notion of arrogance and hence non-arrogance. We will see that a famous problem that was raised initially by Frege and then that neologicists tried to solve, that is the so-called Ceasar problem, is the culprit of this conflict between these three requirements, and we will show that since these, or some of these, have been used by neologicists as reasons to prefer neologicism versus, or neo-Freudianism versus structuralism, well, those reasons may not work. Okay, so I guess everyone here is familiar with the major line of this debate, but I will, just to be everyone on the same page, I'll start with a very brief rehearsal of the two positions at stake. So, in the recent debates in, of course, one part and one tradition of the debate on the foundation of mathematics, there are two major parties. There are others, but these have somehow the attention has focused mainly on these two views. There is neologicism as championed by Bobet and Christian Wright, and especially there are several forms of neologicism. Also, Edward Zalta as a form of neologicism. This is sometimes called Scottish neologicism because it was mainly developed in the Arcade Centre in Scotland, and structuralism. And structuralism, there are several versions. There is Hellman's model version, there is Resnick pattern recognition version, and so on. Here we will concentrate on Stuart Shapiro Antarem structuralism. And the rivalry between these two is mainly a distinction between different ways of conceiving of the subject matter of arithmetic and possibly mathematics generally, but mainly arithmetic. On the one side, we have arithmetic conceived as a science of individual abstract, individual objects, which are abstract objects, they are finite cardinals, they are governed by a given definition or definitional axiom, which is used a principle, and then they have all the properties that are required for those objects to be the natural numbers. And on the other hand, structuralism as a science in which structuralism as a position according to which arithmetic is a science not of objects, but is a science of an abstract structure, an omega progression, which is governed by the Dedekind-Peano axioms that are a different form of implicit definition with respect to use principle, a different form of implicit definition of the primitive notion of arithmetic. Now, essentially, neologicism is the claim that it is possible in a system of fully predicative second-order logic, it is possible to derive the Dedekind-Peano axioms of arithmetic with the sole addition of what is taken as a definitional axioms, use principle. We'll see how it works in a little. Use principle allows for the introduction of certain singular terms, the number of f's, where f is a concept. And these numerical terms, for a number of reasons, are guaranteed, or they are asked and guaranteed to have objective reference. So the singular terms that genuinely refer to objects, or Frege said it, to self-standing objects. Now, if this principle can count as an implicit definition of the concept of cardinal number, and then the notion of finite cardinal can be derived from it. And since it can be instantiated, and we'll see the way by a purely logical concept, then this means that the system called Frege arithmetic, which is the union of second-order logic, fully predicated second-order logic, and use principle, also allows for an a priori access to the axioms of arithmetic, and also proves the axioms of arithmetic to be analytic in Frege's sense, that it is derivable from logic. And the battery abandoned us. From logic, and definitions alone. Okay, no, probably it doesn't always reflect on this. Okay, on the other hand, structuralism is the theory roughly that arithmetic, as any other mathematical theory, is the study of a particular structure, an omega progression, which is the structure exemplified by all system of objects isomorphic, or isomorphic system of objects that satisfy the Euclidean axioms, and the structure is itself an abstract object. When we talk about numbers, actually we are talking about positions in structures, and position in the omega progression. The places of the structure, that is the numbers, are defined merely by relational properties, not by the intrinsic properties of the objects that occupy the position. And the epistemic access to structure can be attained by pattern recognition, even by abstraction principle, but more generally by axiomatic definition, given a background axiomatic theory of structure. Now, we'll focus mainly on neologicism here, to get back to structure in the end. And here the idea is that neologicism has both logical mathematical aims and philosophical aims. On the logical mathematical side, there's a result which is called Frege's theorem, that's been proved by John Bullock and Richard Ack, and is the result that full second order logic and use principle prove Frege's theorems, that is a derivation of the second order Peano axioms of arithmetic. Also, it is consistent, which is something that I was forgetting about. And of course, this is an important technical result because it shows that in the system of Frege's Grundgesetze, one can actually recognize that the appeal to the contradictory notion of extension is essential from basic law 5, so from the definition up to the derivation of use principle, but everything that happens after the derivation of use principle doesn't use the notion of extension in an indispensable way. So the notion of extension can be dropped, and we can try and see whether use principle can be used as an action, as an axiom. Now, from a technical point of view, this can be done, it has been proved, of course. On the philosophical side, the issue is what is the philosophical purport of all these operation, and the idea is that if we can prove that use principle, contrary to what Frege claimed, is indeed a good definition of the notion of cardinal number and the cardinal operator, then the notion of cardinal number can be properly defined, and this overall provides a picture which is both a logicist, although in a qualified sense with respect to Frege's logicism, and a Platonist condition of arithmetic. Now, use principle has at least two features that are relevant from a semantic and analytic point of view. One is that it is analytic of the concept of number, so that it is explanatory of the concept of number. There's a whole bubble of debate whether the notion of analytic used by neologicists is which one is it, and even with the notion of logic, of course, here, but at least it's analytic of the concept of number, and it is a priori. So it can be laid down a priori as a definition, it can be freely stipulated, we can be sure a priori of its truth, and given that it allows the derivation of Frege's theorem, then also Peano arithmetic is a priori and analytic in Frege's sense, as we mentioned. Now, among the many motivations that are offered by neologicists to prefer their own view to rival views, we want to focus on three. All these three concern definition. Clearly, Hume's principle is the pivot in all the neologicist enterprise, so the attention on definition is pretty strong here. Now, the first, I will just give these informally, and then I'll go back to them with also a plethora of quotations. The first is sortality. So, use principle must count as a good implicit definition, not just of any concept of number, but of the right sort of number, and that is, you must define the concept of number as a sorted concept. We'll see what this means, and this was already something that was a requirement laid down by Frege. Also, Hume's principle should meet a constraint that some have seen in Frege's text, starting from Dammit, and that is usually known with the label Frege's constraint, or Frege's applicability constraint, or applicability constraint, and so on. And this requires, in a nutshell, that the definition itself of a given core notion of a mathematical theory is able to give a principled explanation of how that concept, and therefore the theory that governs it, can be applied, especially to non-mathematical domains, but can be applied in general. And this is a requirement of a definition, so we should not lay down the theory and then explain how it can be applied, but we should have that explanation encoded in the very definition. And related to this, there's a requirement that, well, usually not related, one of our points is that it is related. There's a requirement called arrogance, and the requirement is, of course, that since arrogance apparently is bad, is that Hume's principle is non-arrogant. And the requirement is that Hume's principle must be an innocent definition. This roughly means that in order to understand whether the statement expressed in the definition is true, I need to do nothing else than understand what is involved in the statement of the definition. I don't need to look at anything else in order to understand whether this is true. Okay, now I will, the problem that we want to point out here is the following. That there is an interaction between these notions, not always emphasized in literature, and it is the following. Roughly, that sortality can be defended only once the so-called Ceasar problem is solved, but that what we will try to show is that solving this Ceasar problem, as is suggested by the neologicists against Frege, or support Frege's reason, may involve considering Hume's principle as an arrogant definition, and that if we can't warrant that the concept of number is a sortal, then we cannot even explain satisfying the applicability constraint. So either the constraint on applicability isn't met, or Hume's principle is arrogant, or both. And what I try to show is how this possible potential conflict emerges. Shall I take also, I can take also clarification, I don't know what's the structure, if there are clarification questions along the way, or if anyone has clarification, I'm happy to.
I think that the general idea is that if someone has questions, necessary questions. Yeah.
Okay, if you have necessary questions.
As they are postponing to the discussion.
Okay, but just to say, if you have
questions.
Sorry?
Arrogant questions.
Arrogant question are allowed, of course. Okay, so let's start not in the proper order, but let's start from the applicability constraint. Now, here is a general formulation of what is called applicability constraint. Right? Says that a satisfactory foundation for mathematical theory must somehow build its application, actual and potential, into its core, into the content it ascribes to the statements of the theory, rather than merely patch them from the outside. And this is a quotation from a passage of the Blue Gazette where Frege is discussing the definition of the real by Cantor and Dedekind. Now, clearly, we know that Frege is adverse to any empiricist interpretation of arithmetic, so any idea that a specific empirical application must be included, involved in explaining the content of arithmetical statement. But this is not about singular application, it's about applicability. It's about the possibility that the definition lets you understand how you can apply in any case, in any potential instance, the notion which is involved. Now, this general interpretation this general constraint can be given several interpretations, and Wright, of course, tends to give a robust interpretation, which is, as we see, also in line with what Frege claims. And this robust interpretation says that this constraint concerns definition of numbers conceived as individual objects with an intrinsic nature that we can spell out. So it is something, the explanation of the applicability is something that has to do with what the numbers are, what their essence or nature is. And then in particular, of course, according to Frege and the Neologicism, numbers are numbers of concepts, so it explains, must be explained also what kind of entities they apply to, and it is concepts, and it would be sorted concepts. Now, these, there are other ways of cashing this out. So, for example, to get these two specification out, here Wright again that says that he's talking about some principle and some abstraction principle, and he says to view that to take this as mathematically foundational is to view the application of the source of mathematical objects they concern as belonging to the essence of objects of this sort. And here is the way in which this kind of constraint is used against the structuralist. Because Wright says the thought is that the objects, for example, the classical theories of the natural and the real numbers, or of classical geometry, have an essence, individual, intrinsic essence, which transcends whatever is shared by the respective types of model of even categorical second-order formulation of those theories. So, in a way, the constraint is interpreted the constraint is interpreted in a way that makes the connection with the essence of the objects and not with the structure they exemplify, crucial to an explanation of applicability. Hale claims similar things. For example, says that Frege's insistence that the reals be defined as ratios of quantities derives from his belief that the application of reals as measure of quantities is essential to their very nature, and so be built into an adequate definition of that. Now, we will be talking about the constraints about the naturals, not the reals. If you get in the arena of the reals, everyone is fighting with everyone, and even neologists are fighting with themselves. But we'll not talk about the reals, apart from quotation. And again, this is consistent with some passages by Frege and by Dammet, and here is Frege about Dedekind and Cantor about the definition of the reals, and says that either the problem of that definition is that either measurement does not feature at all, or it features without any internal connection grounded in the nature of the number itself, but is merely tacked on externally. This is the same piece of quotation that was in Wright quotation, but it's two different translations of it. Okay, and also Dammet says similar things. Let me skip some quotation. Now, why does use principle meet this constraint? Now, the principle, I guess all of you are familiar with it, is usually quantified by conditional at second order. It's quantified over concepts. It is this biconditional that's on the right-hand side as two singular terms formed by the application to concepts of this singular term forming operator, which we call the number of. And it has an identity statement. It is an identity statement for granted, and not, as in other mathematicians or philosophers, define for numbers specifically, so the identity is in the Lagrange language. And on the right-hand side, we have an equivalence relation between concepts, and this equivalence relation in the case of use principle is a numerosity, that is bijection, 1-1 correspondence. This is an instance of a general form, what are now called abstraction principle, and we'll see another example. Now, Hume's principle, the principle clearly says that the number of the constant f is equal to the number of the constant g, if and only if the f and the g's are into one correspondence, so if the two constants are equals.
Just a question, I don't know whether it's necessary or not, but what's the difference between this definition of cardinality and Cantor's definition? Is there a difference?
Well, yeah, it's not given in the form of an abstraction principle, Cantor's definition, and the idea of the neologicism is that these should capture correctly what is in the essential property of the numbers. Then one other definition that has been explored also by Mancoso and so on is so the connection between Cantor and this is the idea of using equinumerosity, right? Okay, but the peculiarity of this is to cache it out in a specific form of an implicit definition, and that is what explains the role of clarifying the concept and also allowing for the derivation of the axioms. Okay, don't know whether it was a satisfying answer. Okay, sorry. Oh, yeah. They're not sets. Yes, yeah. Clearly, these are not taken as sets or abstract or extension. These are taken like sui generis arithmetical objects. Thanks. Now, Hume's principle introduced the concept of cardinal number, and it does so by establishing the identities condition for numbers as a reference of these terms, and the identity condition are given in terms of the holding of an equinumerosity relation. Now, comparison, according to the neologists, comparison of numerosities is allegedly what underlies attribution of cardinalities to them, and these encloses typical or canonical applications of finite cardinal numbers. Now, there's a kind of a presupposition here that this is the typical way. There's a whole debate whether the typical applications are based on cardinality or ordinality, but this is the contention. And here the idea is that Hume's principle, therefore, encodes a general explanation of what it is to apply finite cardinal numbers. Whereas, on the other side, definition of structure do not seem to encode any specific explanation on how to apply them. Structuralists define a structure by axioms, and after the pure structure is defined, then by means of either isomorphism, homomorphism, several kinds of morphism with partial segments of the structure, or with representation theorems, explains how to apply a given structure. That is the objection that the neologists did move to the structuralists, and the structuralists agreed. And they said, well, we don't care, but yeah, you're right. Then things changed, and there's been a bit of debate in which several positions have been put forward, saying that the neologists are wrong, or they are right, but they are also structuralists are right, and there's, of course, a bit of debate on this if you want to come back to that later. Now, according to Frege, okay, this is the gist of the applicability constraint. There's a specific case that we want to focus on for the applicability constraint, and it is the case of self-application. So application of the concept of numbers. When I say numbers, I would mean finite cardinal numbers, to numbers themselves. Clearly, we know that according to Frege, one of the crucial features of arithmetic is its general applicability. That is what makes arithmetic very intimately connected with the laws of thought, so with the laws of logic. And here are two very nice quotations in the Grundlagen taken by Locke and Leibniz, where Locke says that numbers applies itself to men, angels, action, and thoughts. And when Leibniz says that some things cannot be measured by reason of having no parts, but there is nothing which cannot be numbered, and the number is, as it were, a kind of metaphysical feature. Now, figure. So Now, this general applicability, as we were mentioning before, runs against some definition of natural numbers in terms of specific application. For example, a geometrical definition of numbers. But what is relevant is that Frege himself points out that it is necessary that we are able to apply numbers to themselves. So, for example, we are able to answer the question, how many prime number that are smaller to a given number, or how many even numbers there are between 2 and 47, and so on, and so on. Now, neologists as well give importance to what we call out-applications, so it's arithmetical application to arithmetic, and they say the number theory must be applicable in particular to its own objects, defined cardinal numbers. Since numerical concepts and operations are to be applicable to objects of any kind at all, any satisfactory explanation of them must encompass this generality. So this out-application of the concept of number to numbers is a special case of application, but it's necessary to, it is important for arithmetical practical purposes, but it also is necessary to be accounted for in order to preserve generality. So the constraint must account for it. However, in order to account for it, clearly, since numbers are numbers of sorted concepts, and if we want to have number of numbers, or at least of specific numbers, prime numbers, even numbers, and so on, then we need to be able to characterize the concept of sorter, or concept of number as a sorted concept. So we need to be able to distinguish distinct number from each other, and each number from any other thing which is not number. If you want to know the even number between 2 and 7, we need to know what is a number, and there is an apple in between. We don't want to count that, and then we need to be able to distinguish the 3 from the 4, the 4 from the 5, and so on and so forth. But can we? And here the problem is how we define sorted concepts. Now, Frege himself stated that not everything can be counted. It is the case that the concept to which the number is assigned does, in general, isolate in a definite manner what falls under it. And here the examples are, for example, letters in the word tree, syllables in the word tree, but not all concepts possess this quality. For example, we can divide up something falling under the concept of bread into parts in a variety of ways, without the parts that by choosing to fall under the same concept. Bread, to a concept of this kind, no finite number will belong. So, for example, if that's cherry blue, I cannot ask how many blue there is in that chair, because I can part physically the chair in several different ways. Of course, I can ask how many chairs are here. And that means that blue and other mass terms like water, and as well all vague terms, are not sorted concepts, because no definite number of the objects that fall under them can be identified. Now, in order to have sorted concept, we need to have a concept that isolates in a definite manner what falls under it, and this requires two distinct conditions. One is that the concept is as conditions of identity, and one is that as conditions of application. Here, two quotations from Frege to specify this. As far as condition of identity, Frege says that a number as an object that can be recognized again means that it is essential, in order to understand the concept of number, that we are able to understand whether two terms that purport to refer to numbers refer to the same object, to the same number, or to different numbers. So we need to solve identities like 2 equals 3 and 2 equals square root of 4. And then we need condition of application. So at a certain point, Frege says that all that can be demanded of a concept from the point of view of logic and with an eye to the rigor of proof is only that the limits of its application should be sharp, that we should be able to decide definitely about every object, whether it falls under the concept or not. So identity condition says that if you have two numbers, if you have two terms for a concept, x, you have to be able to say whether these two terms refer to the same object x or not. And condition of application state that whatever object Q you have, you need to be able to state whether that Q is an x or is not an x. And it is only by giving both conditions that we can apply to a concept those numbers, the Anzahlen, which give the answer to the question how many. Of course, Frege defines numbers, natural numbers as kind. Here is a more contemporary characterization of sorted numbers, where I say that a concept phi is a sorted provided that the question how many phi's are there satisfying a certain condition always has a perfectly good sense, so long as the condition in question is well specified. In order to be in a position to find out the answer, we have to be able not merely to distinguish phi from other kind of things, conditions of applications, but to recognize identity and distinctness among phi themselves, and these are conditions of identity. The invitation to number the instances of that non-sorted concept is intelligible only if relativized to a sort. So I cannot ask how many blue, but I can ask how many blue centimeters are, or square centimeters are in the chair. Now, the possibility of out-applying numbers to numbers requires, therefore, that the concept of cardinal number is a sorted concept. And if its principle needs to be a good definition for it, it must deliver both conditions of identity and conditions of application. Unfortunately, it cannot. And it cannot for a problem that already Frege raised, and many of you probably are familiar with. That's called the Caesar problem. Actually, the problem should be called the England problem, because Frege has a different problem a few pages earlier that they uses Caesar as an example, but for reasons that we cannot investigate, it has been famous, as the Caesar problem. This sometimes happens. For example, if you take Benassar's dilemma and you consider its 1973 paper, there is no dilemma, whereas if you consider its 1965 paper, there's a whole section called the dilemma. No one's called the Benassar's dilemma, the one in the 65 papers, but only the one in the 73 papers. So, I mean, this is how things went. And this problem affects the Frege acceptance of use principle as a definition. In Grundlagen, Frege works clearly not with the notion of number initially, but with the notion of direction, possibly because it was easier to understand for his audience. And he says that he formulates another abstraction principle. It has the same structure. It is term-forming operator, identity, biconditional, and equivalence relation between objects of the kinds of A and B. The only distinction is this one. It goes from objects lines to objects, whereas use principle goes from concepts to objects. So there's a difference in levels. I have no idea where I'm going. And the principle says that the direction of line A is the direction of line B, is identical only if and only if the two lines are parallel. And this is a way for Frege to introduce another sort of abstract objects, the concept of direction. Now, Frege sketches an account, and this is the famous passage when we say that we take what is common in the congruence or equivalent relation between A and B, and we turn it into an identity. We replace the symbol of parallelism by the more generic symbol of identity. We remove what is specific in the concept of the former and divide it between A and B. So we carve out the content in a way different from the original, and this yields a new concept. This is a famous metaphor of concept recurring by Frege. But then he raises the following objection, that the definition does not provide for all cases. It will not, for example, decide for us whether England of our Caesar is the same as the direction of the Earth axis. Naturally, no one's going to confuse England with the direction of the Earth's axis, but that is no thanks to our definition. And we want our definition to do this job. We want our definition to give conditions of identity, conditions of application. Now, famously, the objection applies to use principle as well. Use principle delivers all the identity and distinctness truths concerning cardinal numbers expressed by formula of the kind the number of f is equal to the number of g, and the number of f is different. It's not identical to the number of g respectively. However, it is not able to determine the truth value of mixed identity statements, such as the number of f is equal to Julius Caesar. This is, I mean, one can see pretty easily if we have the identity and we want to check whether the identity holds or doesn't. We just take the concept f out of this term, we take the concept g out of this term, and then we investigate whether they are equinumerals. If they are, this is true. If they are, this isn't true. But then, of course, if we have here Q or Julius Caesar, then here we take the concept f, but here we have no concept that we can extrapolate from the name Julius Caesar to take, and then go and check whether the satisfaction condition for the left-hand side is realized by the right-hand side. Now, in general, use principle stays silent for the truth values of statements of the form the number of f equals q, where q is not given in the form the number of f, and it's not previously explicitly defined as an abbreviation for a term of the form the number of f. Okay. This is this called Caesar problem, and this entails that we do not have a genuine concept, especially not a sorted concept, because the Caesar problem is a symptom that use principle cannot deliver conditions of application of the concept of number, and then it cannot solve all identities the statement for number. As regards direction, Frege says, what we lack is the concept of direction. For if we had that, then we could lay down that if Q is not a direction, our proposition is to be denied, while if it is a direction, our original definition will decide whether it is to be denied or affirmed. But we cannot do this. Now, not being able to distinguish between cardinal objects and objects of another kind, use principle cannot establish the true value of mixed statements. And this, according to neologism, also prevents fixing the reference of number terms. Here, there's a quotation for where it says that solving this is a problem is a necessary condition for claiming that numerical terms refer. Now, solving this is a problem is essential to provide an application condition to the concept of number, to certify that use principle is a good definition of the sorted concept, to guarantee that numerical terms introduced by use principle have reference, and then to warrant that numbers are definite individual self-standing objects. But these connect with Frege's constraints in two ways, because the neologism's robust reading of the constraints requires the application to be explained by the nature of essence of the objects defined. If the Caesar problem isn't answered, we don't know what kind of object numbers are, and so we cannot even check whether the definition satisfies the applicability constraint in this understanding. Also, if number isn't a sorted concept, we have no definite criteria of identity and distinctness among numbers, nor among them and non-numbers. And then we cannot counter. Crucially, the out-application of numbers to numbers is bad if the Caesar problem isn't solved. More broadly, generality is lost. There are cases in which we cannot count. If the Caesar problem isn't met, the Frege's applicability constraint cannot be met as well. Now, before considering what happens when we look at the solution to Caesar problem, let us add another ingredient, which is the notion of arrogance. Now, now neologists have argued in favor of use principle as an implicit definition that provides us a priori knowledge. Not all implicit definition, not all definition can say what they call the traditional connection between definitions and the a priori, and the deliverance of a priori knowledge. And there is a class that they call arrogant definition, which doesn't preserve this connection. And here is one way of introducing this notion. Let's say arrogance is the situation where the truth of the vehicle of the, this is rights prose, the truth of the vehicle of the stipulation, the statement of use principle, is hostage to the obtaining of conditions of which it's reasonable to demand an independent assurance, so that the stipulation cannot justifiably be made in a spirit of confidence for free. We need to know something else which is not in the statement of the definition to know that the definition is true. Take a famous example. The example is, let us define the name Jack the Ripper as the perpetrator of the series of killings. This cannot be a definition, because in order to know that Jack the Ripper refers to the man who perpetrated this series of killings, we need to know several things. We need to know that there were killings and not just self-explosions of people, so that there is a perpetrator, and also we know that he has to be unique, and that these crimes were not committed by different persons. So there are two conditions, existence and uniqueness, that cannot be taken for granted just by saying, let us call Jack the Ripper the perpetrator of the series of killings. That makes the definition arrogant. I have to look elsewhere. I have to do what they call some collateral, in this case a posteriori, epistemic work. And again, they say what a good implicit definition should do is that we can freely stipulate it as true without additional epistemic obligation. So there should be nothing else that we should do in order to stipulate the definition. Now, of course, surprise, surprise, use principle is innocent, and the stipulation of the Dedekind axiom by the structuralist is arrogant. And they give reason. They say that let's skip this. Let's focus on the difference. And the difference is the difference mainly is that whereas use principle is a biconditional, whose truth can be appreciated even if we don't know whether there are true instances of its right side, because the biconditional can be true nonetheless. The piano axioms contains either a simple predication, 0 is a number, or existential statements. For any number there is a successor number that entail immediately that state condition that holds only if the numbers exist. Therefore, in order to claim for the truth of the matrix of statements that constitutes the Dedekind piano definition, I need to check whether there are numbers, otherwise the numbers are, the axioms aren't true. This is of course contrary to any Hilbertian strategy of saying that it is consistency that implies existence, but of course we are in a Freudian setting, so Hilbert doesn't count. There's a nice connection between Frege's constraint and arrogance, and the idea that neologists have is the following: that the stipulation of use principle communicates a conception of the objects that are the natural numbers by explaining their essential connection with the nature of cardinality. Whereas again, the Dedekind piano axioms communicate no such connection. So the idea is that if I stipulate the axioms, I am defining, a notion of number that doesn't tell me anything about how can go on and apply it. Whereas if I have Young's principle, the way in which I define the number contain the characterization of the role as measure of cardinality. And this partly also explains the otherness, because everything I need to know for pure and applied arithmetic is already in the definition. I need to do no additional work, whereas in the case of the Dedekind-Peano axioms, in order to know how to apply the theory, I have to go and look how application works. So the Dedekind-Peano axioms fail in satisfying Frege's constraint because they do not communicate any connection between naturals and the application, and this makes the satisfaction of Frege's constraints sort of a litmus paper for checking whether a definition is arrogant or not. Okay, let me use these final minutes to see what doesn't work in all the, well, there's a lot of things that don't work. What doesn't work in this setting. So let's go back to the Frege's constraint. We have seen that in this robust reading, it requires connecting the explanation of applicability to the essence of the objects for the concept of number. This entails the number needs to be sorted, but not just a sortal whose conditions of identity are able to capture such essence. So they give conditions that are that make something essentially a cardinal number and essentially characterized in terms of measurement and comparison of cardinal numbers. This is what has been called a pure sortal. Now, sortality is what we have seen before. Purity is meant to be the idea that if an object is an instance of pure sorter, that it is necessarily so and could not survive ceasing to be so. And the notion of pure sorter is essential to answering the Ceasar problem, because the way in which the neologicists try to solve the Ceasar problem is roughly the following. Formally, we can't do anything. Young's principle is a non-eliminative definition, it's an implicit definition, but we can give a philosophical explanation. And we can give a philosophical explanation by capturing the idea that what Young's principle and any abstraction principle does is the following. It tells you that the concept defined on the left-hand side as identity conditions which are exhaustively characterized by the equivalence relation which is in the right-hand side. As we were saying before, there is nothing more to be a number than to have its identity condition fixed in terms of equinumerosity of constants. However, we can, this is explained by neologicists by saying that we can consider relations of inclusions among constants. And they have a principle which is called sorted inclusion principle. And the prose is not the nicest. A sort of object F is included within a sort G only if the content of a suitable range of identity statements about G's is the same as that of statements asserting satisfaction of the criteria of identity for the corresponding F's. That means ideally that if you take identity statements about persons, and then you go and look whether some of these can be are the same as identity statements among numbers. Now the identity condition about person would be something about having the same DNA and the same spatiotemporal history, whereas those about numbers would be in terms of equinumerosity of concept. There would be no overlapping, so the concept under which Ceasar falls is not a concept which falls under the concept of number. So it is not included. And that gives you a reason for claiming that Ceasar cannot be a number. Any person cannot be a number, and no number can be a person. So if Ceasar were a number, the facts about identity of Ceasar and distinctiveness of Ceasar would be determined by the same facts that determine identity among cardinal number, equinumerosity. But since the identity of a person is not determined by a relation among concept, then Caesar cannot be a number, and therefore the jury of Caesar's sentence is false. Now, the sort of inclusion principle, Prasum's principle, can also be derived this principle, that is an application to the case of number. So G is a concept, sort of a concept of numbers, only if there are singular terms that denote instances of the concept G, such that the truth condition between these two terms from numbers are the same of those of some statements of equinumerosity between a pair of concepts. A number is, something is a number if and only if its identity is explained in terms of equinumerosity of concept. That entails that no number is a human, and let alone Caesar. Now, do we have a solution to all our problems? Now, first, two remarks. One, we already said that the solution is a philosophical and non-technical solution. Hume's principle remains a non-eliminable definition, just for the fact that it is not an explicit definition. And also that the solution does not affect in any way the way in which the formulation or the interpretation of Hume's principle. It just tells us that what is stated on its right-hand side gives exhaustively the identity condition for the sort of object. So the principle that concerns sortal inclusion is somehow not in the definition, it's in the background theory. It's a background theory about the metaphysics of concepts and the way in which they relate or are included in one another. Also, it requires that number is a pure sortal. So to take an example, take the following example. This was raised by Potter and Smiley. The member of parliament of X is identical to the member of parliament of Y, even only if Y and X are co-constituents, so they share the same constituency. Now, this is true. They are represented by the same person, if and only if they are in the same neighborhood, okay? And it is an abstraction principle. However, clearly, this cannot define the essence of being a member of parliament, because the property of being a member of parliament does not define a pure property, a property that an object could survive lacking, could not survive lacking. Of course, someone can be a member of parliament and then stop being a member of parliament. The pure property is being a person. And the idea of introducing pure sortal is exactly the idea of ruling out this kind of, this called additional nature, this kind of problems. So here I have a good abstraction principle that defines an object that should be an individual object whose essential conditions are these, but these conditions are not exhaustive. There is an additional nature to these objects. For example, they are human being. And actually that additional nature is the nature that gives the essence. So we need to restrict the concept of sorting, the sortal inclusion principle to pure sorting. Now, I'm coming to the end. Now, here's a general concern. Now, one of the major claims on which neologicism is based is that Hume principle is the hero. Hume principle can do everything alone. It is just what we need to give someone plus his or her logical background language, and that will deliver everything. Everything from a semantic point of view, from an epistemological one, from a logical one, from an ontological one. However, because Hume's principle must secure meaning and reference to numerical terms, a priori knowledge of the concept of number, a priori knowledge of the Beckett axioms, a priori proof of the existence of infinite many cardinals, Platonism about numbers, explanation of applicability, and so on and so forth. It's a pretty big bargain. Now, one can somehow doubt that, or have a concern that, if everything that is said here works only if I have a solution to the Caesar problem, it's a little bit strange that a solution to the Caesar problem can be given on so much independent background about concepts, their metaphysical status, identity condition, concept inclusion, purity of concepts, and so on and so forth. So this is a general concern. Hume's principle cannot do anything alone as the neologism would require. But let's skip this. The real problem to us seems that sort of inclusion principle and D offer only a partial solution to the Ceasar problem. And the missing part is crucial, and we take it to be fatal. Now, from Hume's principle and the sort of inclusion principle, what follows as best is that no number is a human, and vice versa. Now, the consequence has to do with the suitable hierarchy of sets of identity conditions. So, the identity condition for humans, the identity condition for Roman conqueror, the identity condition for members of parliaments, the identity condition for numbers, for prime numbers, for even numbers, and so on. It's a solution which is based on, but also limited to, an analysis of concepts and their relation. What it does not follow is that any particular individual, for example, Caesar, that same familiar conqueror of Gaul, is no number. And recall Frege's concern. Frege's concern did not request to use principle to be able to treat the following: that for every x, if x is number, x is number if and only if x is not a person. Now, this claim, once we have a definition of the relevant concept, either it is trivial because we can immediately see it, or we need to investigate independently the criteria of inclusion among concepts. And use principle is not involved here. It's something that we do on the concepts that are involved separately. What Frege asked to use principle was much simpler and much harder to apply. That is to solve the Caesar sentence, and hence any Caesar sentence. So that the number of f is equal to Julius Caesar, that the number of f is equal to England, and for any q, then the number of f is equal to q. Now, if we know that Caesar is a person, that q is an x, then the Caesar sentence, or generally the q sentence, can easily be treated by addressing separately the corresponding universal sentence, this one, among the relevant concepts, number and person, generally f and s. But in order to do this, we first need to know that Caesar is a person. And this piece of knowledge, that Caesar is a person, cannot be provided by the standard inclusion principle, cannot be provided by NP, and most importantly, cannot be provided by use principle. What we need to do is to take an object, Q, and determine what pure sortal it falls under. And this will necessarily involve a kind of investigation, be it empirical, as in the case of Jack the Ripper, or a priori, for example, consider trans-sortal identities like the number of the moons of Mars is equal to the real number 2.
Sorry, I don't understand it from the previous logical equivalent.
Which one, sorry?
The fact that something for all x and x if
Yeah.
not the x.
Right? So the idea is that...
so for example, a bottle is a number.
No. What I want to say that is one way of seeing the problem is to ask to be able to say that taken to concepts, okay, I need to be able to claim that everything that falls under a concept doesn't fall under the second one and vice versa, so that they are excluded. Okay, so for example, persons and numbers.
Yeah, yes, but the problem is in the use of the quantifier. Perhaps.
Oh, sorry, in the formulation, yeah,
Yes.
that was right. So, no. Thank you. That went the other way.
Okay. Perhaps we can discuss
this one.
Yeah.
Okay, for every x, n is a number if and only if x is not a person. Yeah, what would be the problem?
Well, the quantifier, then there is a parenthesis for every x.
Yeah.
X is not, what is x? So what's the range of the quantifier?
Oh, okay. Oh, well, well, that's, can I, no. If these were asked to Frege, the range of the quantifier would be the universe. Because according to Frege, concepts are function, and functions are defined universally over the universal domain, and we need to be able, for any possible argument, to say what is the value of the function. So here the idea would be, these rule out that for any object which exists, whatever, even if the notion of universal objects may not make sense, we need to be able to say that it is a number if not and only if it is not a person.
So it is a person if and only if it's not a number.
Right, no, but I see your point now. I see your point now. Yeah, sorry. Yeah, that's badly formulated. I see the point is not the only condition. Of course, I need also to say that for every x, which is a number, it is a number if and only if it is not a person. Yeah, right, yes. Sorry. So it's not the domain the problem, but it is the condition that I have to satisfy in order to fall under the first concept. Okay. Sorry, let me finish. And okay. Now, what we need, however, is not that kind of, to solve that kind of problem. We need to solve this Caesar question, as Frege asked. We need to solve the question, is the number of the moon of Mars equals to Julius Caesar? And this involves necessarily additional work from what we can do by looking at Hume's principle. Now, one can wonder whether this is too much to ask, but according to us, it isn't. After all, in order to derive the Peano axioms, Hume's principle must be able to decide every infinitely many identity and distinctness claim among individual numbers. It has to know that the number of the moons of Mars is equal to the number of the eyes of Andrea, and in test it must solve the difference between the distinctness between 1 and 2, 1 and 3, 1 and 4, 1 and 5, and so on. So it should also be, at least in principle, be able to do the same for any claim involving a number and something that is not a number. But this, of course, makes the principle arrogant. We need to solve the Caesar principle in order to establish the number as a pure sorter. To solve the Caesar problem, we need to know whether Caesar is a person. But establishing this requires collateral epistemic work, whether it be a priori or a posteriori, depending on what Caesar is, and leads to an additional epistemic obligation for the free stipulation of the principle. And these may, quoting the Neologicism, the truth of the vehicle of the stipulation hostage to the obtaining of condition which is reasonable to demand, and so on and so forth, has used principle is arrogant. And this also affects the Frege's constraint, because Frege's constraint is satisfied only if number is a pure sorter. But to establish whether number is a pure sorter, we must solve Caesar problem. And the solution to Caesar problem requires Hume's principle to be arrogant. And then Hume's principle can satisfy the constraint only if it is arrogant. So the idea that the neologicists said above that the stipulation of Hume communicate this connection with measure of cardinality is true only provided we have at least in principle a method for any object at all to determine whether this connection with measure of cardinality is part of their essence or not. If it is, we can ask whether it is the same number of the number of f or not. And this holds for concord, person, chairs, atoms, and motion triangles, and possibly real numbers depending on one obviously real numbers. But the method is bound to entail examining specific, concrete or abstract objects, establishing which sort of concepts, given its condition of application, falls under, and what sort of applies to it. Therefore, in the end, if this is correct, the neologicists need to abandon some of the alleged advantages with respect to structuralism, because Hume's principle becomes arrogant, similarly to the stipulation of the Peano axioms, and either the constraint on applicability is satisfied because use principle is relevant, or it is not satisfying. So no explanation of applicability is actually tied to the essence of the objects defined. And this leaves a plethora of structuralist rejoinders open. For example, one could say that number isn't a solver concept, it's not a concept of objects anyway, or that structural definition of number cannot satisfy Frege's constraint. Well, neither can use principles, so we are on the same par, on a par. Also, one could say that the constraint should not be tied to the essence of individual numbers, should be weaker in its formulation. And when we have a more plausible and weaker formulation, then sure the neologicists can meet it, but so can the structuralists. Or one can claim that reference to numerical terms should not be understood in the Fregean way, but should be interpreted differently. For example, in terms of plural reference, with the background of plural logic, if you want, or in terms of value reference. Now, all of these options have been tried in explored in the literature, and what we only wanted to show today is that possibly the arrogance of that same familiar conqueror of Go may be an unexpected accomplice for structuralists in going for these alternative routes. Thank you very much.
So thank you very much, Andrea. So there's not much time left for questions. So we'll take 10 minutes maybe. Do you have any questions?
Yeah.
So could you please explain me what an application is?
Oh, no. No, but the nice point is that neither can
It's a
then.
very weak part of the general.
Yeah.
Because
It is. It is, and there's much discussion about that on several scores. So, for example, together with Marco Panza, we explored in a paper what it means that Frege's constraint should capture applications. Clearly, it cannot be required to capture any application of the concept of number. The idea is that it should capture what we could claim to be canonical application, but then the question becomes, what are canonical applications? And one can have several kinds of rationale to characterize what concept as canonical. For example, one can have an historical one, the first kinds of applications that were historically used. One can have a cognitive one. So one can say that canonical applications are those that are somehow empirically consistent with our neurocognitive wirings and structure. And there's a whole debate there whether the most basic from a cognitive point of view are the cardinal one, the suitizing faculties, or the ordinary one based on the notion of successor. And then there is ample room of maneuver for the structuralist to claim not only from a cognitive point of view, but even from a everyday observation that maybe basic canonical applications are ordinal and not cardinal. Now, it is essential to the neologicists
it's
that...
also true that when, as long as you deal with finite cardinal numbers and finite ordinal numbers, the problem is distinguished.
Right. Yeah, but there's also another. That is also came up in the literature in the debate, but it was clear.
For example,
It was
you said how many numbers are between
Yeah.
three. This is not a cardinal notion, of course. This is an ordinal.
well,
you
yeah.
you need to have an order.
Yeah, you need to have an order. Yeah, it depends.
Otherwise, I can see that 1,000 is between
Right, you need to have an order, but the point is whether the order is enough or whether the order is something that follows from the properties of the individual numbers. And if you look at the derivation that you can give of the Peano axioms by use principle of Frege arithmetic, clearly all the order properties follow, because they must, but they follow because the number are...
It's an induction. It is an induction.
No, because induction is not assumed. Induction is just a consequence of the way the individual numbers are defined. They are defined in a way that allows induction to be satisfied. Whereas on the structuralist, on the dedicated, on the stipulation, you have an axiom, of course, an axiom of mathematical induction. That was a major difference between Frege and Dedekind. But it was clear since Dedekind's work that if you have Frege's definition in terms of objects, then as cardinal, then you can recover all the ordinal properties. And if you have Dedekind's or structural definition of numbers of naturals in ordinal terms, then you can also recover all the cardinal properties. And that's been pointed out recently by Shapiro, saying, look, there's a sort of mirroring on the idea. So if we have room for claiming that the basic applications are ordinal and not cardinal, then we are really on a par. You look for cardinal application, but then you need to derive the ordinal properties. We look for the ordinal application, and we can derive the cardinal property. So actually, we can both satisfy the constraint one way or another. But I totally agree that a weak...
But you are, well, when we talk about application,
yeah.
We apply what to what?
According to this Phrygian...
individual numbers or numbers?
According to this Phrygian picture,
what's the application of 3?
Yeah.
It makes no sense.
We apply individual numbers, which are abstract objects, to concepts. That is the basic Phrygian picture, which can be questioned in several ways. But so, very briefly, there's a kind of application that answers to the question of how many that can be answered even without having order properties. Whereas if you have a structure and you want to apply that structure, you need the order properties, because in that case you need to have equivalent an isomorphism between the target system to be counted and an initial segment of the structure. That is the basic idea. Then I have written and argued that it is wrong, but that is the basic idea.
Perhaps we have to stop.
Yes.
I also wanted to ask a question, but I can't. And there's also...
Yes.
It is just interesting that in category theory, in modern category theory, there is a notion of natural number object. But this does not design an individual number, but the collection of all numbers.
Right.
And actually, they want to find properties characteristic for this collection of all numbers. And there is a famous paper by Bill Lovier where he shows that there are different characterizations of the collection of all numbers. One of them is the Dedekind-Peano axioms, and then there are two others which are more categorical in nature. But so somehow mathematics show you that you can develop an axiomatic system, or a system of axioms which characterize the collection of all finite numbers, but this system is not unique. And finally, what you want is actually not uniqueness of such a system, but you want to apply these axioms in order to have theorems about natural numbers which are true. So I think it is somehow, for a mathematician, it's very strange to see that there is so much struggle with the notion of definition. Just a mathematician, he puts his definitions and he uses them. And then afterwards, it's empirics, which shows you whether he has put the right definitions or the wrong definitions. But somehow to say that the definition is good because it's self-evident, for any mathematician will say you that it's nonsense.
Thanks. Quick reaction. Thanks. I didn't know the paper. I'll ask you for the reference, and it will be very useful. And for all the rest of the discussion, there's clearly a background point. There's a conflict here between philosophy, mathematics, and philosophy of mathematics. And depending on how the two or the three are interact, you can have different answers. Clearly, from a practical point of view, there is a range of freedom. There's a degree of freedom which is much ampler, much wider than what is considered once you have some philosophical constraints on the background. And that is also the reason why structuralists, but the same argument you can make it with category theory, are much more consistent with mathematical practice, which usually the interest is in the structure and with no regard of what the properties of the objects are, and I can have alternative structure, isomorphic, non-isomorphic, I can have different kinds of application. And there's been a debate with mathematicians on this, saying, look, why advocate so much about application? Application is made by representation theorems. Okay, and there's a nice paper between Batinsky and Bob A on this. Here, the problem is that there is a broadly Freudian, if you want, or Aristotelian or Euclidean foundational perspective in which what we are trying to do is not just deliver any theory that can work as arithmetic. We want to reconstruct arithmetic, which is taken to be one and only of specific object with specific nature. Then if you want to talk about that thing in infinitely many other ways, we know we can do it. We can do it for any practical purposes, but that is not the philosophical aim. For us, the structuralist is completely different. Thanks a lot.
Maybe because we are saying, you can ask a question.
It's a short question.
Okay, very short.
Thank you. Total concepts, pure total concepts, aren't they akin to ordinality? And what could be the connection from the 3 points of view: philosophical, philosophy of mathematics, and mathematics? The question is short, but the answer is not.
No. So the question to the last part, what is the relation in general? I have no idea. I have few ideas, which means that I have no idea. But as for the former, thanks. I haven't thought about it. I'm not sure whether the notion of pure sortality has any connection with the notion of ordinality. There can be some of the connection that were brought before, that in order to count something you need to. But if ordinality means putting into a specific sequence that object that satisfies a given condition, that the notion of pure sorter should be indifferent to it, because what only would care is that certain objects satisfy a certain condition, so fall under a concept. Then counting those means putting concepts into correspondence, and that may involve using a notion of order, or it means using a relation of equinumerosity that might entail the notion of isomorphism. So we need to see whether order is somehow sneaking behind that. But as just sortality is involved, what is enough is that objects satisfy a condition, not whether there is a specific order in which they do so. That would be my first answer.
So you mean you mean it's difference between something local and universal?
So you can ask questions privately. We're not in a time to discuss during the post, but we have to stop now. So thank you again.
Thank you.
Particularly I appreciate in view of the general organization of these meetings that you in some sense you show that there's philosophy, mathematics, and logic, and you have to cooperate, but it's not so simple, because
It's not so simple. It's not so simple, of course, when you look at real mathematics and mathematical practice.
But it's important yes, for you.
Yeah, sure.
This is what you also will be that. So thank you again very much.
Thank you. Thanks a lot for your questions.
So we make 15 or 20 minutes pause. We resume at 11:15. I think we will have to go.